Okay, let's do sulfur.
Almost done.
Again, you don't have to draw out the orbital diagram if I don't ask you for it.
I kind of like it.
Yeah, I mean, it helps, especially at first, to figure out what your electron configuration is going to be. So I'll just do it this way, and then we'll write the electron configuration. All right.
So on 2, you don't have a D.
All right, so I have 16 electrons. I go to my 1s orbital, fill it up, 2s, fill it up, 2p, fill it up, and I've used 2, 4, 6, 8, 10. 10 of my 16 electrons. So I go 3s. 1, 2, 1, 2, 3.
You can fill it up.
2. How many do I have?
You can fill that 3p up. 4. No,
4.
Wait. Yeah.
Yeah. I go back and add
I did 1 extra.
Okay, so my electron configuration then would be sulfur. Then I did 1s, 2, 2s, 2, 2p6, 3s, 2, 3p4. Alright, so did we talk Tuesday about the Pauli exclusion principle? Well, you already know it, kind of.
Dr. Majors gave us this, and it's pretty helpful too.
The quantum number thing, yeah. I think it doesn't have Pauli exclusion on the bottom of that.
Sure it does.
Yes, ma'am.
Where does 3D hit on
3D. In between 4s and 4p. Right here.
Oh, so it doesn't.
Because 4s is lower in energy, that's where we put it. We put it in between the 4s and the 4p. The reason each of these orbitals can only hold 2 electrons is because of the Pauli exclusion principle. Alright, so Pauli exclusion principle says no 2 electrons can have the same 4 quantum numbers in a given element. That is why you can only have 2 electrons in each orbital. Because the first 3 quantum numbers describe the orbital. The last quantum number, which is your spin quantum number, describes the actual electron. So in order for them to not have the same 4 quantum numbers, their m sub s values need to be +,
So what does the MS stand for?
The spin quantum
Okay,
number.
spin column, okay. So they spin up,
Spin up and spin down.
So does that mean orbital values?
Go to what?
Spin versus the mass?
So we're only looking at the actual electrons. So like, let's apply now quantum numbers to what we're doing here. Usually how I ask this question on a test is once you have written your electron configuration, your orbital diagram, I ask you to assign the 4 quantum numbers to the last electron you placed in one of the orbitals. In the last orbital. So for our case, the last electron went in the 4p orbital. But remember, it's the one that was spin down because we filled all these up, then we went back. So I would ask you for the 4 quantum numbers of that electron. Okay? How do I get that? Your N is right there. Your L is right there.
and you would just do the down spin. The one
Yeah,
you
but
circle.
we gotta do the M sub L first.
Okay.
So what is L? What number is it equal to if I have a p orbital?
And the p orbital,
1.
a half.
Your L value for p orbital is always 1.
Okay.
Remember? L 0, 1, 2, 3 corresponds to
That's why.
P,
Yeah.
D, F. Alright, my M sub L values are always related to L, and they're negative L to 0 to positive L. So my M sub L values for P would be negative 1, 0, positive 1. Y'all remember that? M sub L, negative L. It's like a number line. You start at the negative L, you go all the way to positive L. Okay, well those 3 numbers correspond to these 3 orbitals. So, this is how you'll express your 4 quantum numbers. N is 3, L is 1 because it's a d orbital. My M sub L value is going to be negative 1 because my last electron is
Was
in
negative.
the negative 1 orbital. The M sub S is negative 1/2 because it's spin down. Okay, so that would be my last quantum number.
So your N is 3. L is 1.
This is a p orbital. Then M sub L values are always negative L to positive L.
So that M of L is negative 1 because the last electron was the
In that.
was the spin down. And then the M of S
That's why
is the quantum number, and
or
it's,
S.
yeah.
For the electron because it's spin down. It's negative 1 M sub L because it's in this orbital.
Right. It's making sense.
Good. Alright, let's do, let me make a note first. Let's do one in the D block. Okay, let's do iron, Fe.
Iron.
Mm-hmm.
I'm gonna do what? And it's got 26 electrons.
Yes, you got a lot of electrons to place.
So take a minute. Yeah, we got it down.
So much easier to do than this thing.
I agree.
So much easier.
Yeah, there's one periodic table that I gave y'all on. See how it's marked out? Here's the 4s2, 3d10, 4. Y'all can use this and go through and write 5s, 4d, etc. So when you're working, you know your D is always less than the purity.
Thank you.
So alright, you want me to do the orbital part or just go to the electron configuration?
I want to make sure I did the sort part right.
Okay.
Because I did the whole thing, if you don't mind.
That's fine. Alright, so we always start at 1s, 2s, 3s.
3D.
You gotta go 4s first.
Oh, 4S first. Okay, so I did it wrong.
Then
Okay.
3d.
Okay, so I did it. I'm glad I got you to do it. Because I went to 3D
Right after.
right after, yeah.
Alright, then I have 26 electrons, so let go.
Okay, I'm glad I got you to do it. I got it now.
Okay, so that is the full orbital diagram. Lucky for you, you will not have to draw the full orbital diagram on your test. We'll simplify it in just a second. All right, so here's my orbital diagram. Let's go ahead and write the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then back to 3d, and I put 6 in the d orbital. Y'all get that as your electron configuration. You have to go to the 4s before hitting 3d.
That's where I messed up. I'm glad I got you to
Write it out.
to write it out.
Okay, so let's assign the 4 quantum numbers to that last electron again. So again, this is the order and the notation you use to express your 4 quantum numbers. So what's my N? 3. What's my L? 2, because it's a d orbital. My M sub L, -2. If you're not sure where I got that, my M sub L values, negative L, positive L. So I start at -2, go to +2. The last electron lands in -2 orbital. Then it is spin down, so
-1.
Yep.
Okay, so you got the 3.
from here.
Okay. Alright.
And D L. The reason we call these SP DF instead of using the L value is because if I have 3 and then I just put a 2, that looks like 32. It doesn't look
Right.
like you're in their L value. So that's why they gave them names, orbital names.
Got it.
Okay. So now let's simplify. Because if we're talking about an element way down at the bottom of the periodic table, I ain't really trying to start at 1s and go all the way down. Take me a while. Okay, so we can use what is called the noble gas configuration.
Everybody wants to be a noble gas.
Yes, they do.
Waters. That's hilarious.
Okay, so the reason Noble Gas 1, not only is it more efficient, but it shows you the actual electrons that we're even interested in. My core electrons are everything below this red line. Essentially, they're just squatting in that atomic orbital, not paying rent. They just hanging out. My valence electrons are the ones we care about. They're going to form bonds with other elements to make compounds. We call those valence, I think I already said that, valence electrons. So we can simplify this by using the noble gas configuration. This all corresponds to argon. How do I know that? Well, if I go to the third energy level, I go through the s orbital, then through 6 places through the p orbital, I arrive at argon. So we can abbreviate all this by using argon. Then we'll just show the valence electrons because that's what we're interested in. And so, how do you find the noble gas? But you're always going to use the preceding noble gas. So say I was going to do magnesium, I would use neon as my noble gas. Then I would start at the 3s orbital. Okay.
So if you were using magnesium, now why would you use neon?
You always go to the preceding
Oh, preceding. Okay.
noble gas. So my noble gas configuration would be AR, 4s2, 3d6. Let's do one more example with the noble gas configuration. Let's see. Let's do calcium. Alright, so I locate calcium.
Go to noble gas.
I go to the preceding noble gas, which is argon.
argon.
So it'd be CaAr. Then what orbital am I in? 4s, and I go over 2 places, 1, 2. So calcium would be
Do that again.
argon,
So
4s2.
you go to calcium.
Yeah.
Go to argon, and then what 2 places did you do?
I went 4, this is 4, this is the s block, so 4s, 1.
Ah.
Stepping stones. Y'all are really gonna like the F block.
How do we get to it?
Let's see that. Found those are just extra elements that they threw in there. I don't think we should do them.
Yeah.
I mean, they just they couldn't even put them in the periodic table. They don't
They're
care.
too big.
They're just too much. They're extra. That block should be really interesting. Because it's going to be Would that still be in the 6th and 7th orbital?
They're 2 behind.
Or what?
2 behind.
Uh,
So, let's look at, go to the 6th period. Periods are, rows. 6th period, this periodic table that I gave you is the easiest to follow in terms of getting to the F block.
Yeah.
So what happens is I go 6S, 2 places. Then I'm in 5D for 1 place. Then I drop down to the F block.
Okay, so after
I know.
5D.
Just skip, I didn't say that.
Oh, I see where it cuts off.
Yeah, so it cuts off where I've drawn this bold line.
After the
Lanthanum
lanthanum.
and actinum, that is where your F block goes. And D is 1 behind the number out here, the period, like 4S, but I'm in 3D. The S are 2 behind. So down here, I'm in the 6th period, so 6S, but 5D. Lanthanides are 4F.
Lanthanum starts the F's.
Cerium starts that down here. So the lanthanides are the 4F. Actinides are 5F.
Okay.
Supposed to make all these recordings. I guess I should talk to the camera.
And actinides are 5F's.
So let's do a fun example. Let's do promethium, 61, element 61. Let's do promethium's noble gas electron configuration. Then we'll do the orbital diagram just for the valence electrons. Then we'll do the 4th quantum layers.
Okay.
All right, promethium is PM.
61 electrons.
All right, let's use the noble gas. This is even funner. All right, so here's promethium. Promethium is in the 6th period. So I go to the preceding noble gas in the 5th period, and that is what? Yes. All right, in case y'all didn't follow, let's look. Here's promethium. Promethium would be inserted right here if we used a longer piece of paper. So I'm in the 6th period.
Oh, I gotcha.
So preceding would be xenon.
Okay.
Okay, so now let's pick up where xenon leaves off. I go 6S, 1, 2. Put your noble gas in brackets. 6S, 2. Then, according to the periodic table I gave you, you step in the 5F zone 1 place. You have to jump to that 1 place, so 5D1. Then you enter the 4F. Okay? So I have to go lanthanum, then drop down. From there, I'm going 1, 2, 3, 4 places into the F orbital.
Hold on, wait. So 5. 5D.
Because it's in the F block.
Yeah, pointed up here.
Okay, so I go 6S, 2, 5D1, then I drop down to 1, 2, 3, 4. 4 places and then 4F. Right here. This is the D orbital, remember?
Oh, okay.
So I have to step there in order
Oh, yeah,
to
'cause
get
we're in
in.
the S. Then go to the D. I got you.
Starts at 4F and then it goes.
To 5D, yeah, because
Cause you move over into the D.
if I was going to fill up the entire F orbital and jump back, that would be correct. But because I'm staying in the F block, only step one place in.
Ds.
So, if we filled up all the
Same
electrons, say we went to,
Yeah,
would
I'll
you
do
do
that.
5D
I'll do that.
one and then 4F, and then would you go back to 5D?
Yes, so good point. So let's now do one that is in, oh, I wanted to do more.
Yeah, we'll finish this and do another.
If I'm going back into the D
Cause we
block,
crossed over right into the D.
okay, so say I'm going 6S, then I go 5D1, then I'm trying to get to say platinum. I've still got to go through this 4F block, then I jump back up to my 5D orbital, then I go over to platinum. So when you do that, you go back and add your D blocks together.
So
Okay.
the D blocks start at lanthanum and then,
Here's the D
I mean, the
block.
F, I'm sorry, the F, but the F block starts back up.
Yeah.
I mean, the D block
It's-
starts back up at
It's
house
inserted in the
yeah,
middle of
of
the D
these
block.
two, right there. These right here, that's where it's inserted. Okay, and then so when you come back up, you start back over right
At
there.
5D. All right, so let's draw this orbital diagram because we haven't done one with the F. So the nice thing about the noble gas configuration, you're only showing the valence electrons. Those are the only ones I'll ask you to draw out on your test. So if I asked you to draw the orbital diagram, it would be 6S. D. Technically F is a little higher in energy, but 6, 7. So I put 2 electrons in my S, 1 in my D, then go to my 4F.
Fill it up, then you can go back.
Yeah, if I was.
If
but
you had
for
to, yeah,
open
yeah.
term, I don't.
Okay, I got you.
So the last electron would be in the 4F, not the 5F. Oh, I mean, 5D.
So this orbital diagram really does help those and those two.
Everybody get that for your orbital diagram? Any questions?
There's your last one.
So let's do the 4 quantum numbers. What's my N? 4.
N is 4.
What is my L?
L is F.
Which corresponds to 3.
3.
My M sub L, I'm going to start -2, -1, -1. I mean,
So the M's of L is going to be 0.
so it's in the 0 orbital in the F block, so my M sub L is 0. I'm spin up, so
Half, positive 1/2. That's your MS.
Would you go 5D above 4F and
okay, let's see what time is it.
11:13.
Y'all try to get through 1 through 5, and I'll try to go over them before we leave. So what I've given you you're either given the element, the electron configuration, or the orbital notation. Oh, sorry. You've got to fill in the rest of the table.
When it's saying the orbital notations, that's the last orbital.
Yes.
Go back and look at the ones we've done.